You know that feeling, right? You get a brand new, expensive piece of tech. You pull it out of the box, and the very first thought you have is, oh man, I am absolutely going to break this thing. Well, for new drone pilots, that feeling is magnified by about 1,000. It's this universal fear, and the drone community has some, well, let's just say some very direct advice on how to handle it.
This is hands down the best piece of advice I saw on Reddit for a first-time pilot. It just perfectly captures that mix of pure excitement and absolute terror. And it sets up a really fundamental problem. Flying a drone is hard. It's not like a video game. The stakes, a crumpled several $100 piece of machinery, are pretty darn high.
So, before we get to the robots, let's start with us humans. What does it actually take for a person to fly one of these things without immediately plowing it into a tree? Well, the community has some seriously good tips. Now, you look at a list like this, and it seems simple enough, right? But what's fascinating is that these aren't really about the drone's mechanics. They're about managing the pilot's brain. Find an open area. That means fewer things you have to keep track of. Understand the flight modes, because, sport mode can get you into trouble fast. And don't get cocky. Probably the #1 cause of pilot error. Every single one of these tips is about lowering the incredible mental load on you, the human pilot.
And that really gets to the heart of it. It's not just a checklist you run through. It's a whole new way of thinking you have to adopt. And one user on Reddit had the absolute perfect analogy for it.
That's it right there. When you're flying, you can't just stare at the pretty camera feed. You're constantly scanning your surroundings, checking your altitude, battery levels, speed, orientation. Your brain is processing dozens of things every single second just to stay stable. That constant multitasking, that situational awareness, that is the exact problem we would have to solve if we wanted a machine to do this. And that is the multi-million-dollar question, isn't it? What if we could take that entire stressful human cognitive load, the scanning, the checking, the worrying, and just offload it to the drone itself? What if a drone could actually think like a pilot? Well, guess what? That isn't science fiction anymore. It's actually the focus of some incredible research from a team at MIT. They set out to build a system that lets a drone navigate completely on its own, even in places where our most basic navigation tool is totally useless. And here it is. This is the star of our show. Now, it may not look as sleek as a consumer drone, but this machine is an absolute genius. Its whole mission is to fly into a place it has never seen before, with zero access to GPS, and not only figure out where it's going, but build a map of the entire area while it's flying. Okay, so this is way, way harder than it sounds, especially for a flying robot. A robot on the ground can be big, it can carry heavy computers, and if it gets confused, it can just stop and think for a minute. A drone can't do any of that. It has to be light, it's naturally unstable, and it can never, ever stop moving. It has to sense, think, and act all in this constant, high-speed loop just to keep from falling out of the sky. So how did the MIT team pull this off? They basically gave the drone a brain with 3 different levels, each running at a different speed. Think of it like your own body. At the lowest, fastest level, 1,000 times a second, you've got the lizard brain. It's just handling basic balance, not tipping over. A level up, running about 40 times a second, you have your reflexes. It's using a laser to see and dodge stuff right in front of it. And then you have the slowest, most strategic part, the master planner. This is the part that takes all that data, builds the big picture map, and decides, okay, let's go explore that hallway. It's just a brilliant way to divide up the work. So that middle and top layer, the sensing and the mapping part, that's where the real magic happens. So how does a robot, with no eyes and no GPS, figure out where it is and where it's going? Well, it uses a concept that is absolutely fundamental to modern robotics. It's called SLAM. Just imagine you're dropped into a pitch-black maze with only flashlight. You have to start drawing a map of the walls you can see, but to do that, you also have to keep track of where you are on the very map that you're drawing. That's SLAM. You're doing both at the exact same time, and each task actually helps the other one get more accurate. And this is how the drone sees that maze. On the left, that's what we see with our eyes, a normal photo. But on the right, that's what the drone's laser scanner sees. It's not a picture, it's a 2D slice of the world, represented as a cloud of super precise data points. To the drone, the world is pure geometry, which is perfect for a computer to understand. But its perception is even more sophisticated than just seeing walls. I mean, check this out. Look at the railing in this picture. The drone's algorithm is smart enough to see that some laser points are hitting the railing, but others are passing right through it and hitting the wall behind. It can actually distinguish between the foreground and the background, building a much more complete map. It's an incredible level of detail. So the theory is brilliant. The system is super elegant. But does it actually work? This is where we move out of the lab and into the real world. And honestly, the results are just stunning. Okay, get a load of this. On the left, we have the official architect's blueprint for a building at MIT. On the right, that's the map the drone built, in real time, while flying completely by itself. I mean, the accuracy is breathtaking. It captured that complex, weirdly shaped layout almost perfectly with no prior information at all. And it's not just for indoors. They took this thing outside into what they call urban canyons. You know, those spaces between tall buildings where GPS signals are notoriously awful. And the drone successfully navigated a 700-meter flight path around the campus, again, building its map as it went. But the ultimate validation, the real trial by fire for any research like this, is putting it to the test in high-stakes competition. And for this team, that meant the 2009 International Aerial Robotics Competition. And the mission they had to complete was just insane. The drone had to start outside, find a 1 meter by 1 meter window, fly through it with only centimeters of clearance, explore an unknown maze inside, and find a specific target, all with zero human help. And here it is. This is the proof. This is the actual map and the path the drone took. Starting from the left, it flew in, it intelligently explored the maze, and it found the target. The whole thing was over and done in just 4.5 minutes. The team didn't just win. They made history. In the 19 years of this competition, no team had ever completed the mission in the very first year it was introduced. This wasn't just a small step forward. It was a revolutionary leap in autonomous flight. So this takes us all the way from a Redditor's simple advice, keep it in the box, to a machine that can navigate the most complex places we can imagine, completely by itself. It really makes you wonder, now that we've taught them to see and think in our world, what new worlds are they going to show us? What will they explore next?